diagram to I want to use this diagram to introduce the definition of a crop rotation. I guess everybody know that, to just review that. This diagram was developed by the ministry to encourage mainly conventional producers to adopt crop rotation with a 4-year fall crop as an example. And the crop rotation is defined as a planned successive cultivation of a series of different crops in specific order in several years on the same field. My computer doesn't want to move. Okay, here we go. Rotating crop provides many advantages and benefits. Some benefits will show in a fairly short period of time. Others may take quite a few years or even a decade to demonstrate. One of the benefits is improved soil fertility because different crops will use different nutrients would have a different nutrients need. And a post crop would fix nitrogen if you incorporate that post crop into your rotation. And another one is better control weeds because different crops have their own agronomic differences. So this kind of difference would break weeds life cycle and suppress weeds growth. And apparently, rotating crop would reduce the pressure of pests and disease, mainly because plant disease and pests are host specific. Change crop would block those kind of life continue and make them difficult to spread. Increase biodiversity is another benefit. Not only you add crops into your rotation, add crops, but also increase some microbial diversity inside the soil. And because of this improved soil nutrient supply and diversity in soil microbes, and this make your crop systems more resilient, and a lot of times reflected by the crop yield increase. In general, these 10 principles should be considered as a guideline when you choose your crop for rotation. There are, I list those 10. The first one is the following cover crop with a higher nitrogen demanding crop, or you could grow a flax after a cover crop. That would increase your flax yield up to 50% based on SCIC's data in past 10 years. So that would produce a tremendous amount of financial return if you do that. And then second is growing less nitrogen demanding crops in second and third year. Number 3 is don't follow one crop with another closely related species because they might, attract the same kind of disease or insects. Number 4, use crop sequence that promote healthier crop that will follow. And number 5, use crop sequences that would help control perennial weeds. And we will discuss this in details when we come to the examples. Number 6, use perennial crops on sloping land for a longer period of time. And number 7, try to grow a deep-rooted crop after shallow-rooted crop. Number 8, grow some crops that will leave a large amount of residue to boost your soil organic carbon pool. Number 9, grow intercrops such as cereal with legume or oil seeds with legume for effective nitrogen utilization or help to fix more nitrogen. Number 10, incorporate multi-species cover crop in your crop rotation to increase nitrogen fixation and promote biomass production. And number 10, we are going to talk about cover crops in next meeting. So we will go a little bit detail on that one. And come to the crop selection for rotation, uh, we probably should choose a shallow rooted, follow, rotate shallow rooted with deep rooted, because the nutrient use efficiency, shallow rooted crops would suck up the moisture and the nutrients from the cultivated zones, like in 6 inches or 12 inches area, and deep rooted could go down a meter and scavenge the nutrients from the lower horizon. And then when those crops died, they would put those nutrients back onto the surface layer. And then if you grow shallow rooted crop, then they would have more nutrients to absorb. And use a heavy feeder and light feeders to balance the nutrient usage, and use susceptible crops. This will be referred to the pest and disease to those are affected, and a break that would be able to break the pest and disease cycle. I want to say that susceptible crops, I didn't mean that same crops, but with some are more susceptible, or others are not. And for that particular crop, and you should choose those are unsusceptible to the pests variety always. And the example I could give is, if you have to grow, a peas, pea is more susceptible to many disease compared to other crops. But if you grow pea, you do have to grow pea. But in that pea category, you choose the resistant varieties, not to choose those susceptible varieties. And the other one is early, late seeding crops. And this would benefit for weed control and short season, long season crop rotation. And particularly this would refer to the cover crops, and also think about spring seeded and fall seeded crops, and break weeds growth cycle and control perennial weeds. But this is the consideration for this is also applicable when you choose a crop species for your cover crop and intercropping. So legume crop is a lifeline for soil nitrogen sources. Always think about legumes and add legumes into your crop production where and when it is possible, either as a mono cash crop, or part of the intercropping, a penning crop, or shorter season cover crops. May work in some area, may have difficulties in other places, but always think about that when you do this. The next one would, I think this one, Martin and have talked about that nutrient budget, and I use the example that Martin gave on his presentation. I use the data, but I add those kind of fancy graphs, stole them from internet and make it look better. We will review the nitrogen balance as what Martin talked about. If you grow a common wedge with a dry matter of 4,000 pounds per acre, and which contain 2.5% nitrogen for a cover crop in year one, and you basically add 100 pounds of nitrogen into your soil. And the second year, you grow a wheat crop. If you got a 30 bushels per acre yield with 1.9 pounds per bushel nitrogen is required, you basically taken out 57 pounds of nitrogen from the soil. Now you have 43 pounds left in your soil. And what you third year you grow a flax. If you got 14 bushels per acre yield, And each bushel of this flax would use 2.12 pounds of nitrogen. So you would take another 30 pounds of nitrogen out from your soil. Now it got 13 pounds left for your crop. What are you going to do with this 13 pounds of nitrogen? Apparently 13 pounds of nitrogen doesn't really support a good non-legume crop production. You could grow an intercrop, and that's another choice. That's one choice. Another one, you could return to a cover crop. So use this 13 pounds of nitrogen to support a cover crop to grow. A lot of times, this nitrogen, what we aim to do is to balance this. You could have 2 crops or 3 crops that use up all the nitrogen put back into the soil in the year 1, but not to create a deficit. Let's say, in 3rd year, in 4th year, this, can you see my cursor? You got 13 pounds, you could grow another cereal crops. For example, if you go back to wheat, and this 13 pounds even cannot support 10 bushels of wheat per acre yield. And if you grow wheat, what would happen? They probably you would have more than 10 bushels per acre of yield, but the crop actually dig into your organic matter to use the nitrogen from there, and your organic matter in your soil would reduce. And this is something you don't want to see. And we would use that as an example. The key thing for the nutrient budget for crop rotation, one is producing a profitable crop, and number 2 is to maintain the system sustainable, and number 3, and that I think is more important, improve the soil health whenever it is possible, not try to degrade it. So if I were you, I probably won't use up this 13 pounds of nitrogen. I would go back to a cover crop. Let's look at some examples. The first example is 2 years rotation, and some producers are using the 2 years rotation, 1 cover crop and 1 cash crop. I would think they use this kind of rotation to build their soil health. Otherwise, I think financially it might not viable. I did talk to Marian Fernandez from AFC in Swift Current, and she told me that some producers do use this kind of rotation. But apparently, if you do use this kind of 2 years rotation cover crop, and then the cash crop, you need to grow a very valuable cash crop like a flax, which worth a lot of money. And when you have a high nitrogen supply, as I said earlier, SCIC already indicate that following a cover crop, the flax yield could be increased by 50%. That's a tremendous benefit for that. And the second example is 3 years rotation. You grow a cover crop, and then you grow a high nitrogen demand crop, wheat, and you could have not only high yield, but also high protein content. So that would help to achieve your financial goal. And 3rd year, you could grow a flax. And this is exactly example we use for the nitrogen budgeting. So even you grow a wheat with 30 bushels per acre, and with 14% of protein content, you basically use 57 pounds of nitrogen, and then the nitrogen left over from this crop still support a good flax production. Example 3 is 4 years crop rotation. After cover crop, you grow a flax, or you could grow a wheat, as what the previous example said. Well, if you grow a flax, we have been talking about flax is not a hydrogen demander. Well, it use about if you're looking at 14 bushels per acre yield, it will use 13 pounds of nitrogen, and then the leftover will be able to support a good oat production, because oats doesn't need a whole lot of nitrogen. You could get 60 or 70 or even higher oats yield, but still got enough nitrogen supply for that crop. And then you could go back to the intercropping, because the nitrogen left from this flax and oats rotation is not enough to support wheat production. So if you grow intercropping wheat or faba bean, faba bean would be able to fix nitrogen to support its own growth and leave all the soil nitrogen for wheat to use. And a study have shown that when you grow this kind of two crops together, the legume would be able to transfer some of the nitrogen fixed from the air and supply the wheat to grow. And Jeff Shino's study have shown that some from 9 to 49% of nitrogen, 49 to 41% of nitrogen from the companion crop. The legume supply 9 to 41%, 41% of nitrogen that the companion crop needed. So that's a tremendous amount of nitrogen. And when this crop harvested, the faba bean residue would be going back to the soil, provide a little bit more of nitrogen for cover crop to start with. This is example number 3. Number 4. Number 4 rotation was designed for Canada thistle control. Before you go back, what you could do in that case, in year 1, you could underseed yellow sweet clover to a wheat, to a cereal crop, either wheat or oats. And after you harvested the cereal crop, the clover start to grow a little bit. The year 2, the yellow sweet clover would start early, and they could start. They grow fast, and they produce chemicals to eliminate the Canada thistle to grow. And by July, early or middle of July, the yellow sweet clover start flowering. That time you could terminate it. Either use creepers or use tillage. The tillage would help this kind of cover crop residue turn into organic matter and decay quickly. In later fall, like end of August or early September, you could seed it a fall rye into the same field, because fall rye is a crop that also produce chemicals that affect, that really eliminate Canada thistle to grow, and which is called allelopathic in scientific term. And then the fall rye would have a huge growth power, particularly after the cover crops. They have lots of nitrogen, and then they grow fast. They overgrow the Canada thistle, plus the chemicals that extrude into the soil, and the Canada thistle will be greatly suppressed. And actually, so after this foray, you could either go back to cover crop, like, or you could grow another cash crop. But this time, if you feel the soil nitrogen is not enough, you could grow intercropping. For example, pea with mustard as an example over here. And you could also grow other kind of things in there. And then before you go back to the cover crop. This is the rotation design to control Canada thistle and not lose the financial returns on your field. The example number 5 is, if this example, I would think as a special mission for Canada thistle control in organic cropping systems. And when Canada thistle pressure is very high, you can grow alfalfa for hay for a few years. Not only can get the weeds under control, in the meantime, you will not lose financial, oh, I'm sorry. You won't lose the financial returns. Yeah, that's the probably good option for your systems. What I want to say is, when you grow alfalfa, you do need to think about weed control, mechanical weed control, because when alfalfa is small, it doesn't have that kind of huge suppression power. So you do need to help alfalfa to establish with mechanical control. In the meantime, phosphorus is required to grow a good alfalfa crop. So that's the two things you need to consider. Alfalfa can also be a good crop for transitional period producers when they prepare their land for organic production. In 2 years, transition period, you could grow alfalfa. Yeah, this is my short presentation. And yeah.
Perfect. Thank you so much, Dunling.
I hope it's not a repeat Martin's talk. I try to avoid that.
Yeah, no, and I really appreciate it. And yeah, also just going to stop the recording now.